In the previous video, I've told you that hybridization intermixing of the two orbital of exactly same energy or same energy to form a new orbital of exactly same energy. For example, we have discussed the carbon excitation state and all that. So this is the orbital it is formed. This is S and P. But we can see that these are the different orbital, or intermixing can be only happen between the orbital of same energy or nearly same energy. So what we're going to happen that this orbital intermix. This is 1s and 3 orbitals of p and 1s. So this will be sp3. 4 orbitals will form because number of mixing orbitals is equal to hybrid orbitals. This is pretty obvious. sp3, sp3, sp3 and sp3. In this way 4 orbitals are formed. And what's the shape of methane now? I'm not writing the shape of methane right now. I'm just only telling you the hybridization. We already know the SS, SP, PS, S. So this is sp3. Here we're going to write sp3, 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 and yet again sp3. And the exact shape of this orbital is like this. This is carbon. Okay. This is only a rough shape. I'm sorry, I might have mistaken. Okay, let me make it again. It's a little bit messy. Okay. This is tetrahedral shape. Now I'm only telling the name, that I'll be discussing each and every shape and the short trick to find out the hybridization in a few seconds. That what's the process and everything later on. But this is only a rough idea. Okay, this 4 orbitals try to remain in the space in a such way that there would be a minimum repulsion between them, due to which they develop a geometry and they're responsible for the compound geometry. They try to remain in a such way that the repulsion between them will be minimum. So what's the key point? The first key point that we have is that intermixing of the orbital must have same energy or nearly same energy. The second that we have that same orbitals, which orbitals overlap. Now question arises that which orbitals overlap. Only half-fill, full-fill and empty, all type of orbital overlap with each other. There can be it can be half-fill over full-fill. And half-fill is that by mean of full-fill is we have example of lone pair. Empty we have coordinate covalent bond, and this is simple covalent bonding, coordinate covalent bond. In this way the orbital intermix with each other. Now the key point is that they are named after their parent orbital, orbitals. For example, 1s and 3p combined plus 3p, 1s and 3. So there will be sp3. 1s plus 2p combined, sp2. 1s, 1p combined is equals to sp. So in this way they are named after their parent orbital. You can't intermix this orbital 1s and 2p. There is a large energy difference, but you can intermix this because of the very less energy difference between both of them, right? Now I'm going to discuss that the basic terms like 1s plus 1p, 2 orbitals form sp. 1s, 2p, 3 orbital form sp2. Number of atomic orbital that are intermixing is equal to number of hybrid orbital. Remember this is always 1s plus 3p with the 3p orbitals, which is sp3. 1s plus 3p plus d. Then it will be 1, 2, 3, 4, 5 orbitals will form, and it will be sp3d. 1s plus 3p plus 2d. So this will be 1, 5, 6 orbital will form, which is sp3d2. sp3d2 and 6, in this way 6 orbitals are formed. Now I'm going to discuss about the shape of orbitals. We know that generally now there's a difference between shape and geometry, right? In this, like in hybridization, we mostly discuss the geometry. We don't discuss the shape here. For example, the shape of S is spherical, the shape of P is dumbbell, and the shape of G is double dumbbell, like this. Right, this is the shape. But if we talk about the geometry of hybridization, we mostly consider this structure. This is a large lobe. Whenever you see this structure, just remember it's a hybridization process. Large lobe. This is a small lobe. Right. So this is for sp, sp2 and sp3. For example, sulfur structure. This is something like this. This is also a hybrid orbital. So then this way we discuss about the hybrid orbital. Let me see that any point is missing or not. So that I can discuss here. Yeah, these are the only points that are here. So this is here till shape. Now next I'm going to discuss about the shapes orbital, geometry, not shapes, I'm mistaken. Now the geometry of orbitals, examples, and type of